In 1979, Cessna sold over 1,000 twin-engine piston aircraft. Today, they build exactly 0. The piston twin is dead. Industry analysts declared it obsolete decades ago. Insurance companies treat them like ticking time bombs. Flight schools abandoned them. Even manufacturers walked away. But somehow, impossibly, a small Austrian company is building the most successful piston twin in modern aviation history. The Diamond DA62 defies every rule that killed its competitors. It burns less fuel than some singles. It flies on engines the entire industry said would never work. And here's what should terrify Boeing and Airbus about this little airplane. It represents a philosophy that could reshape aviation itself. The story of how the DA62 exists at all reads like a corporate thriller. Betrayal by a supplier, a bankruptcy that should have ended everything, a desperate gamble to build their own engines, and a final vindication that nobody predicted. But the DA62's success reveals something far more important than one company's survival. It exposes the stagnation that has paralyzed general aviation for half a century. Why did every other manufacturer abandon this market? The answer will fundamentally change how you think about what's possible in aviation. Here's what the aviation industry believed for decades. 2 engines meant twice the safety. If one failed, you simply flew home on the other. It was elegant, reassuring logic that sold thousands of aircraft throughout the 1950s, 60s, and 70s. Pilots considered twin-engine ratings essential credentials. Manufacturers couldn't build them fast enough. Then researchers actually examined the real crash data. What they discovered demolished everything pilots thought they knew. Engine-out accidents in twin-engine aircraft were 4 times more likely to be fatal than forced landings in singles. 4 times. Think about that. The supposed safety advantage was actually killing pilots. Asymmetric thrust at low altitude demanded split-second decisions that many pilots simply couldn't execute. The second engine wasn't saving lives. It was taking them. The market collapsed with stunning speed. In 1979, Cessna alone sold over 1,000 piston twins. Today, they manufacture exactly 0. Beechcraft builds perhaps 1 Baron per month. Piper's Seminole exists almost exclusively for flight schools. Insurance premiums skyrocketed. Training requirements intensified. And then Cirrus delivered the final blow with their airframe parachute system, making singles safe enough for anyone unwilling to master the dark arts of asymmetric flight. The piston twin became aviation's dinosaur. Obsolete, abandoned, finished. But here's what nobody anticipated. While American manufacturers fled this dying market, a small Austrian company saw opportunity where everyone else saw only extinction. Diamond Aircraft, led by the relentlessly innovative Christian Dries, made a decision that defied all conventional wisdom. They didn't just stay in the twin market, they revolutionized it. In 2004, Diamond introduced the DA42 Twin Star. This wasn't your grandfather's twin. All composite construction, diesel engines burning globally available Jet A fuel, FADEC digital controls that eliminated the complexity that killed pilots. The aviation press was skeptical. Industry veterans predicted failure. Instead, Diamond captured 80% of what remained of the piston twin market. Their aircraft compiled safety statistics that seemed impossible. Fatal accident rates 1/6 of the general aviation average. No stall-related accidents. An overall record that made single-engine competitors look dangerous by comparison. Diamond had proven the skeptics completely wrong. Their diesel twins weren't just viable. They were fundamentally transforming expectations about what small aircraft could achieve. Then in 2008, everything Diamond had built came crashing down. Their engine supplier imploded in spectacular fashion, taking Diamond to the very edge of extinction. What happened next would either destroy the company entirely or forge something unprecedented. The engines that powered Diamond's revolution had a fatal flaw. Thielert aircraft engines had promised reliability. They delivered disaster. Gearboxes failed with alarming frequency, requiring expensive factory replacements every few hundred hours. Maintenance costs spiraled beyond anything owners anticipated. Warranty claims overwhelmed the German manufacturer. Then investigators discovered something far worse than engineering failures: financial irregularities, criminal investigation. The words "no supplier wants" associated with their company. In February 2008, Thielert filed for insolvency. The insolvency administrator immediately cancelled all existing warranties. Spare parts became impossible to obtain. Hundreds of DA42 owners found themselves grounded indefinitely, their aircraft rendered worthless by engines nobody could service. Diamond's production lines fell silent. In July 2008, the company officially suspended DA42 manufacturing. Picture this nightmare scenario. You've built an entire business model around revolutionary diesel technology. You've captured 80% of your market. You've proven every skeptic wrong. And now your sole engine supplier has imploded, taking everything with it. Diamond faced three options. They could abandon the twin market entirely, following every other manufacturer into retreat. They could search for alternative suppliers, except none existed that could match what Thielert had promised. Or they could attempt something that bordered on corporate insanity. They chose insanity. Christian Dries and his team made the audacious decision to build their own engines. Austro Engine GmbH was born from desperation. Diamond partnered with Mercedes-Benz, utilizing their proven 2-liter diesel block as the foundation. Bosch provided the electronic controls. The company poured everything into development, racing against financial collapse with each passing month. Here's what makes this gamble extraordinary. Certifying a new aircraft engine typically requires years of testing, millions in investment, and regulatory patience that small companies rarely possess. Diamond accomplished it in 13 months. In March 2009, the European Aviation Safety Agency certified the Austro AE330. The engine delivered 20% more power than Thielert's design while burning less fuel. It eliminated the problematic gearbox clutch that had caused so many failures. 1 month later, Diamond delivered the first Austro-powered DA42NG to a customer in Sweden. The company that nearly died had emerged stronger. They now controlled their own propulsion destiny. But survival wasn't enough for Diamond. They had far more ambitious plans. They were going to build the airplane that would prove everyone wrong about twin-engine aircraft forever. The DA62 wasn't simply a larger DA42. Diamond reimagined everything that had doomed piston twins for decades. Every criticism, every complaint, every fatal flaw received a systematic engineering response. The result was an aircraft that shouldn't exist according to conventional aviation wisdom. Start with the problem that matters most to operators: fuel economy. Traditional Avgas twins burned 30 gallons per hour or more. The DA62's upgraded Austro AE330 engines deliver cruise performance on just 11 to 12 gallons total, not per engine, total. That's comparable to high-performance singles while carrying 7 passengers instead of 4. But here's where Diamond truly rewrote the rules. Twin-engine complexity has killed countless pilots who couldn't manage propeller pitch, mixture controls, and throttle coordination during emergencies. The DA62 eliminated all of it. Single-lever FADEC control means engine management requires nothing more than pushing a lever forward. Start the engines by pressing a button. Feather a failed propeller by flipping a single switch. The system handles everything else automatically. And that's single engine service ceiling that traditional twins could never deliver. The DA62 maintains positive climb at maximum weight up to 13,000 feet on one engine. Lose power departing Denver, and you can still climb to pattern altitude. That's not incremental improvement. That's fundamental transformation. Now examine the number that silences every remaining critic. Since Diamond introduced their twins to the American market in 2006, they have recorded exactly 0 fatal accidents. None. Their overall accident rate runs 1/6 the general aviation average. No post-crash fires in company history. The aircraft that insurance companies once feared has become the safest piston twin ever manufactured. The market noticed. 273 DA62s delivered through early 2024. Government surveillance contracts across multiple continents. Assembly operations expanding to Brazil. Even German Chancellor Friedrich Merz chose the DA62 for personal transportation, publicly noting it consumed less fuel than official limousines. Critics predicted the piston twin would never recover. They declared diesel aviation engines permanently unreliable. They insisted composite construction couldn't match aluminum durability. Diamond proved every prediction catastrophically wrong. The DA62 exists because one company refused comfortable surrender. When suppliers failed, they built their own engines. When markets collapsed, they created new ones. When experts declared something impossible, they did it anyway. That philosophy contains lessons far beyond aviation, and understanding why matters more than you might expect. The piston twin died because the aviation industry stopped trying. Manufacturers accepted that twins were too expensive, too complex, too dangerous. They retreated to designs from the 1960s and called it good enough. Diamond refused. When their engine supplier collapsed, they built their own. When insurers demanded impossible premiums, they engineered an aircraft so safe it rewrote the actuarial tables. When pilots said twins were too difficult, they created single-lever simplicity that rivals a Cessna 172. The DA62 exists because one company asked a question nobody else would. What if we actually solved the problems instead of accepting them? That's the real lesson of this airplane. Not that twin engines are secretly viable, but that aviation's supposed limitations are often just failures of imagination dressed up as physics. The industry that put humans on the moon now struggles to improve a bonanza. Something is deeply wrong with that picture. The DA62 won't replace airliners. It won't revolutionize mass transportation, but it proves that small teams with relentless focus can still achieve what giants abandoned. And if you want to see what happens when that philosophy scales up, subscribe. Because the next revolution in aviation is already taking shape.